This is how we do it,
Day 1. The team has 72 hours to complete a huge aerial engineering project.
Welcome to IT Hell, folks.
With no previous briefings, they have no idea what they're walking into.
Saving the world here, one cable at a time.
The challenge is transmitted.
Hello, crew. My research team has brought some new information to my attention. As you know, time is one of the most crucial aspects in emergency response scenarios. According to current data, the average arrival time for first responders is 10 minutes. In densely populated areas, emergency vehicles average 1.5 road miles at 35 miles per hour. Here's your challenge. Develop a UAV that can respond in under 5 minutes. Travel 1.3 air miles with a top speed of 100 miles per hour. Carry a small payload, which has been provided. If you succeed, your project will be added to the vault. Best of luck.
All right, let's see what we got in our payload. Oh, we got some water. That seems like a heavy load right out of the gate. We got an emergency blanket.
It's just basic, like, first aid stuff.
Some first aid gear. It's
Just
pretty heavy
generic.
though. It's pretty heavy.
Yeah,
We got to do 100
that's
miles an
nice.
hour. That's not going to be easy.
Because we're trying to shorten emergency response. If it takes 10 minutes, even 1 minute, you know, people's lives could be in danger, right? Let's build the world's fastest drone. We can finish the 1.3 miles in like a minute. We just saved many lives. 9 minutes faster.
We gotta talk about numbers now, right? So why don't we just do the math? Because the motors are the most inefficient portion of the whole rig.
But as long as it
Going at
gets
100
there,
miles, but going 100 miles per hour.
So if you run a bigger prop, slower RPM.
The team can use high voltage batteries to add extra power and flying time, but at the expense of additional weight and drag. The team will need to find efficient motors, props, and speed controllers to maximize thrust and longevity from a small battery.
Don't we need the ESCs to at least compensate for any type of burst?
2K motors, you're going to be pulling some serious amps.
Once the electronics are mapped out, everything must be mounted to a lightweight frame. It's got to be sturdy enough to withstand payloads and G-force, but light enough to allow a sustained 100-mile-per-hour flight. With so many trade-offs at stake, this build is starting to look next to impossible.
we gotta find motors that can take the voltage, and we gotta find the prop and ESC combo because of the amperage that props can cause. If we can find the perfect balance between those three things, I think we got ourselves a first responder drone.
All right.
With a rough blueprint mapped out, it's time to hit the warehouse.
This is called the Jerry-mobile. It's for transporting Jerry's.
No, we need a charger.
On today's shopping list, motors, batteries, speed controllers, and a ton of luck.
Batteries?
Some batteries.
All right, we can play with those.
All right, so we still need speed controls.
What? No.
Get up. Let's see, we got some batteries.
We got motors.
All right, so we got some 2600 kV. Those are very high-speed motors.
You know what? We can always throw it on the bench, see what it's going to pull before we put it out there and break it.
I agree.
And all of that to bring a little bit of water, huh?
I think what we need is just a very basic kind of a pod design.
The project is making headway, but the most crucial element to the design is still missing, the frame. This component will serve as the central support structure for the battery, motors, camera, and electronics. Unfortunately, nobody currently sells anything built for speed and capable of carrying a payload. The team is going to need to design something themselves.
Well, that's all of you. I don't know any frame makers. You're the guy for that.
There's no room to mess this up. Luckily, Cornell has a friend that may be able to create exactly what they need. If he can design and machine a frame based on the criteria needed for the challenge, they won't have to waste time modifying something off the shelf.
Talk to you soon. Bye.
All right, so frame's good.
Jerry starts engineering the payload drop.
I don't know why these people think it's so hard. It's just so simple. You just get a box like this, fly up, and just, see, just simple that way. You know? Hey, we're free!
That was 100 miles an hour, and we already lost our keeper flap. So I don't know if that's gonna fly. Oh well.
We got nothing.
Henri Brownell is a drone guru. With several years of experience in drone technology and frame development, his knowledge and skills are extremely valuable. Hopefully, he can help the team engineer the perfect frame.
Come on in. What you guys up to today?
Well, so I need a drone frame from you.
Yeah, so you're telling me.
Yeah, so I'm hoping we can build a frame from scratch if we got enough time.
Sure. Got a good place to start from, too.
Oh, yeah?
So,
All right, let's check it out. We need to build the world's fastest drone.
So, okay, that works. Well, let me go ahead and we'll just start up a new file here, and then I'm just going to load the base plate, and then we'll just start with that because I think that's going to be the most important thing to modify and tweak toward your design anyway.
To ensure quick production time, Henri is modifying one of his latest models to suit the team's needs. This specific frame has vertically mounted arms to reduce drag and maximize thrust. However, everything needs to be prepped and cut today.
Again, do the double check.
All right. Perfect.
The design is ready for cutting. Back at the warehouse, the Jerry and Chris R&D team began testing the electronics. Well, they were supposed to anyways.
I'm gonna try and run into that.
So Chris,
Yes.
we're missing something on this board right now.
I see frame, speed controller, motors, props.
Flight controller.
Pretty much the entire brain of everything. We don't need GPS.
We do need GPS if you're going.
I mean,
We're flying a mile and a half
for
away.
initial
We're
test.
flying a mile and a half away. There is no way in hell you're going to be able to see anything past 200 feet from naked eye. You're just having a drone in the sky that has no clue where it's going, and now it's more of a hazard than a tool to be used.
Who are we gonna get a board from? Because I'm familiar mainly with the acro stuff.
I know EMAX is making a new one.
All right, you want to give them a call, see what they got?
Yeah. Hey Sam, how you doing, buddy? Good, how are you? Hey, we're running into a minor situation here. We're working on a project. They want us to fly 1.5 miles out. We're looking for a flight controller right now. Do you guys carry anything that might have maybe a GPS or some type of system we can communicate at long range?
Yeah, actually we do.
Do you guys have any in stock right now? Because we kind of forgot about it last minute, and it's kind of due tomorrow.
Yeah, of course. No, we have it in stock here in the U.S. So,
Awesome.
stop by our office.
All right, thanks, Sam. We owe you one. Hopefully it's like a
You
big
really want
sucker.
that GPS, though?
Do you trust me flying manual out there for a
I don't
mile
trust
long?
you, I trust me.
Let's go.
The drone needs to be flying by tomorrow. While Jerry and Chris try to track down a flight controller, Henri and Cornell head to the shop to start machining the frame. If everything goes according to plan, the electronics will be ready to mount by the end of the day.
I think we're good being handicapped parking. I mean, Jerry's handicapped mentally anyways, so.
Hello? Is anyone home?
Flight controllers are microcomputers that serve as the central processing and software hub for all functions of a drone. Thankfully, EMAX has one in stock that is compatible with the team's build. Designed by the EMAX crew, product manager Brandon Cruz brings Jerry and Chris up to speed.
We have our own harnesses here that you'll be able to plug into the ports, or you can solder direct to any of the connections.
Yeah, this is gonna be a small little fun project. Thank you,
Yeah, no
Brandon.
problem.
Thank
Thanks.
you,
Bye,
sir.
guys. Yeah.
And with that, they leave with the controller they need and a little EMAX swag.
Shirts,
Ooh, sorry, tattoo.
hats, and some lanyards.
Thank you.
See ya.
Let's go back home.
Back at the shop, Henri and Cornell make progress cutting the frame.
When I first started doing this would always freak me out.
All of a sudden, something goes wrong.
The CNC machine ended up kicking out one of the pieces that we were cutting out. Because of that, we had to stop the machine, and now we're gonna have to reprogram the machine to cut in a different way that will prevent it from picking up pieces out of the sheet and flinging it towards us.
Prop testing begins. It's long, rigorous, and stressful. Data from motors, props, and batteries must be analyzed to attain maximum thrust efficiently. If the team screws this up, they won't hit 100 miles per hour. Thankfully, after a little bit of troubleshooting, the machining process continues. The final pieces are cut, and it's time to go home.
Damn it. All right, one more time. Ready, Chris? 1, 2, 3.
What up, guys?
Oh! Hey! Hey, we're working.
Basically, we didn't get as much done as I'd hoped. It was more theoretical in a sense. No real world finalization on anything. I've been testing some props, but we couldn't find all the ones we were looking for.
These 2600 kV motors that are meant for speed ain't doing it.
We gotta get the thing built and tested tomorrow.
We did find a few pitfalls and things we have. I think tomorrow's gonna be the bigger day for testing and getting it all working.
These are my final results that we're gonna go with 6. APC 6" by 4.5s.
Ooh.
Yeah, the new ones. They're a little bit bigger.
Okay. We have a custom cut frame that has vertical arms. And I mean, right now it's in pieces, but it is designed to fit all our needs. Yeah, I think hopefully we'll make good progress tomorrow. I think we're onto something. So we'll see where to go from here.
Day 2. All hopes of productivity are thrown out the window. I mean, what else are you supposed to do when you're surrounded by gadgets?
That's the indestructible 100-mile-per-hour frame.
I'm going to be programming our flight controller.
Oh, I think it's coming together fairly well now.
I'm feeling pretty confident right now. We're a little on a crunch for time in order to finish building the drone, but you know, we've all built plenty of drones before. I think we can pull it off real quick.
Is there a concern?
I just need to get back to assembling and stop being bothered with all these interviews.
I gotta go.
Chris mounts the flight controller to the base of the frame to make room for the motors and speed controllers.
Okay, so this is the front of our quad. Where's this receiver going to be sitting? Because I can tie into any of these battery leads.
So on this design, they want the receiver on the very top of this.
Okay.
That's where the receiver for the RX should be. And, oh my God, that's butter. God, it just sits so nice and snug. Holy crap. I'm nerding over this. I am nerding.
It's really good engineering,
Yes.
huh?
And now for the moment of truth.
We're just doing a quick power up test just to see if we're actually getting 5 volts. Because I've built quads before where I've assumed there was 5 volts coming from somewhere, and it was an input, not an output.
I had no hands in the electronics for this build.
All right.
It works!
No initiation, we're good.
We got
So
5 volts. So we got what? 1, 2, 3, 4. Am I looking at that right?
yes, sir.
Notice how intricate the wild Chris is. Now, shh, let's sneak up on it and not disturb its nesting procedure.
Let's distract it with snacks. Let's see if he makes any noise.
There's nothing left. I already checked this.
Oh no, we've been found. Run!
Open your mouth. Open your mouth, Chris.
I'm good.
After yet another failed attempt at distracting Chris, Jerry and Cornell prep batteries and start work on the camera module.
Can't clamp it in because
That's our carcass. It's coming together. Wiring's actually fairly clean for being a brand new build I've never worked on before.
Final assembly begins.
So put tape on here, now just reverse it on here. You want to show off the name or show off the back?
I want the heat sink out.
Okay.
I think those are classy looking speed controls.
All
Now to figure out the payload.
I'd rather do like a little Ziploc bag or something like this, where people can just kind of rip it off. Oh, it fit.
Do.
Beautiful. All right, so now we're good?
Yep, we're good. Let me finalize the screwing for you guys. Make it nice and
And just
clean.
like that, the build is finished.
Damn, that is a freaking sick clean. Like,
That's freaking sick clean. I like your wording there.
it's a freaking sick clean.
Finally, before the drone can fly, software must be installed and configured to the flight controller. The core functions of the quadcopter need to be manually programmed to ensure the flight hardware works as expected.
Why is this not loading?
Trouble begins.
If you're connected to Data Flight, it won't connect.
I don't have beta flight on. So now this time I plug in the battery and it freezes. You use the 5-volt lead to power the board, right? Mm-hmm. And it's just freezing.
Try 4, see what happens.
Yeah, froze.
Yeah, that's not a good sign.
So basically we hit a little problem. We got the racing drone built. It's all together. It is a beauty. However, The computer, the onboard computer we installed, looks like it might be faulty because it keeps freezing up and we can't fly. So right now we're trying to figure out troubleshooting, and if not, we might have to just replace that control board and try something else. You try changing tabs now.
Cornell disables software parameters on the board and the flight controller boots. After a stressful night, it's ready to fly.
It's perfect.
It's alive.
High five! Yes!
Put some props on it.
That is what we do. That was really hectic, but props are on, motors are spinning correctly. Want to take it outside?
Give it a quick test.
All right, let's do this. Arm, everything looks good.
It works, and everyone is in good spirits again.
It worked! It's working! It's working! Woo!
Everything is ready for tomorrow's big challenge.
That's it, baby. That's it.
The
You want to try?
No.
Hey, Jerry's
No?
back.
No, not before
Come on,
the
dude.
no, not before the test. No.
Not before?
I'll do it.
Jerry! Just
What the hell? Dude, I didn't even freaking get it to even lift off for a second. What the hell?
I don't do
I
this
barely
thing.
even tapped it and just unbelievable.
No. Still armed?
Yeah. What the frick? Is it dead? Don't touch it, man. Is it still running? Yeah. What the frick happened? It says it has connection.
Yeah, that can't be me, right?
The drone is damaged. Things are not looking good.
You only did 2 screws per motor.
That still wouldn't cause it. not
That
to
wouldn't cause
disarm.
it. Because I moved one notch, that thing took off on its own.
No, I think initially it's
Cornell,
just...
Cornell. From my point of view,
Mm-hmm.
you cannot take away my point of view.
Right.
This is what happened.
It's pretty tense right now. Everyone's a little on edge.
One notch on the Tyrannus, it already went that way. So you're the programmer.
Yeah.
What happened? Could be a board. I wasn't there for programming. I wasn't there for the setup or the tuning with the ESC. So but it was still running.
Right. That's
Then
what we
it-
can't figure out.
Okay,
So
so
we
then it
go
kicked up on
around.
its own.
I double check. It's still not. It's still. It's
So-
disarmed. It went wacko. It wasn't responding to my remote. It started flying on its own underneath the car. Last thing I want to do is stay up all night trying to fix this. I'm almost wanting to just rip out the board and throw in an older one that I'm very familiar with that I know works. At least I can guarantee, I'm not going to have problems tomorrow morning as I try to do the challenge. So I don't know.
Well, sorry about the props.
You might be sorry about the quad. In my experience with all these quads, nothing's easy. This is like the cutting edge of what's out there. I've had my fair share of problems, but it is pretty frustrating tonight.
Just having to be patient with everyone and have us all work together to solve problems one problem at a time. And then I think we can get through this together as a team.
Hopefully we get it figured out, otherwise we're going to be taking the entire thing apart and...
Okay, replace the board. We're not going to have that crap out like outside ever again. What?
Failed.
It failed.
So
The thing just
the
failed.
STM
That's gotta be a bad board.
STM32. That's a bad
That's
board.
a bad board.
Because right now it lost connection during serial programming. All it has
And now
is
the
power
board's
enabled.
bricked. Also, now it's brick, so it's just goner now.
Their biggest fear was correct. The flight controller is bad. Luckily, Cornell found an older model that they can try to use for the build. The quadcopter will need to be gutted to get this part replaced. Chris takes up the challenge.
Group hug.
No, we gotta rub his
I'm going to maintain what I'm doing. We got one shot. It's like 8 Mile over here. You guys are f***ing around.
Cue that music.
And I'm trying to...
Cue that music.
It's one of those progression issues where you think you solve it because it works, but in the back of your head, you're not sure why it happened. You don't just fix the problem and move on. You got to find out why it went bad in the first place. We got 3 guys who build quads all the time, and something's happening, so.
The repair is complete. This is their last chance to get this right.
4 motors?
2 pizzas in, he's
Because
talking
it's
like
more
this already,
fun,
man.
dog. It's way more fun. All right, children.
I'm not part of this. I fixed it and I put my hands up.
Watch, I'm gonna touch the stick and it's gonna be 100% my fault again.
All right.
The final flight. If the new flight controller doesn't work, they're out of options.
No, man.
I'm gonna get over here. All right, you guys ready? All right, hover test. Here we go.
Throttle's not enough.
And land.
The ECUs are synced.
All right.
All right, now this is the problem. Was the second time it took off.
Wait, let's replicate it. Hand me the controller.
That was quite an adventure, but you know what? We got through it.
And then let me which button?
We found out we had a bad flight controller, and it's as simple as desoldering wires and putting new flight controller in.
So this is exactly the same scenario.
You know, we scrapped it, we put in a new board, and it is flying like a beauty. It is great, and I really look forward to our challenge tomorrow.
I put it straight up. We go home now? Home now? We go home now.
Today didn't go the way anybody expected, but through trial and error, the team managed to solve some incredible issues. The true test comes tomorrow, attempting to sustain 1.5 miles at 100 miles per hour. If this works, the team may shed some new light on how emergency response situations are handled.
We went to the coordinates, and we're at a racetrack.
It all comes down to this. Their drone must hit 100 miles per hour with a full payload. Oh, and to keep the teams on their toes, there's been a surprise element added to the challenge.
On the horizon, I see a challenger.
Well, I guess the surprise is we have a race car coming.
What's up, guys? I'm David Allen. Today, I guess I'm going to be teaching you guys. Oh, what's up, man?
Hello.
Okay, a little weird, but I appreciate it. Today, we're going to be doing a challenge where we're going to be racing my ambulances versus your ambulances, and we're going to see who wins.
What kind of an ambulance are we talking about?
Have you seen these JDM ambulances, my friends? This is the pinnacle of Japanese ambulance technology.
The drone not only needs to hit 100 miles per hour, but it also needs to outperform a high-speed emergency response sports car.
Let's do this.
Okay, guys, let's have a clean, fun race here tonight. Arm checks, pilots.
Arm.
Car check, driver. Here we go. 3, 2, 1.
That was amazing.
Awesome. I'm landing.
Great job.
I think we got whooped a little bit. Just a tiny bit.
With an overwhelming show of speed, the drone dominates the race with an easy win. More importantly, they hit 100 miles per hour and sustained 1.3 air miles with the full payload. The team now awaits the final verdict.
That was one of the most craziest things I've ever done. I mean, we went through so much trouble trying to get that thing working. As far as whether drone ambulances can be a thing, I think it is a definite yes. Drone ambulances, in a way, can help deliver emergency supplies to people in need much sooner than it takes for emergency response to get to an area.
Definitely the concept was there. We do need to spend more time with design, but overall, executed well done.
Yes.
You can determine if it's, water or if it's food or whatever it is, and you can coordinate an aircraft to come in, land, give the supplies, give the immediate attention, and potentially save lives.
Hopefully the stigma that's been revolving around this society for the last 10 years has slowly dissipated with at least our example of what we could do. So next time I get to fly the stuff, right?
Of course.
Through trial and error, the drone hackers used cutting-edge technology to build their own solution to a potentially life-threatening problem. If the project gets added to the vault, it will receive approval to be studied for future applications. From here, the challenges are only going to get bigger. We say, bring it on.
I must admit, I didn't think you guys were going to be able to pull this one off. You've left me with no choice but to mark this an overwhelming success. I can't wait to share your discoveries with the rest of my team. Well done.